Hello students, welcome back to these chemistry sessions. Today we are going to talk about chemical properties of carbon dioxide gas. Chemical properties, this is the same as chemical reactions of carbon dioxide gas. So every time when we say chemical properties, we mean chemical reactions. So for example, number one, I'm going to start with the reaction between carbon dioxide gas and burning or with burning magnesium ribbon. Okay, let's start. Magnesium, when it's burning, check this statement, burning magnesium ribbon, it produces a lot of heat. And if we remember from the reactions with air, magnesium burns with nitrogen because magnesium produces a lot of heat, which has the ability to break the triple bonds in nitrogen gas, thus reacting with nitrogen to form magnesium nitride. So I need us to look at that property. So because here we are dealing with burning magnesium ribbon produces a lot of heat. Now this heat, the heat produced, breaks down the carbon dioxide gas to form carbon and oxygen. That is carbon dioxide gas, the heat that has been produced from burning magnesium, we form carbon and oxygen. Now, this carbon is observed as black particles on the sides of the gas jar. That is, if we had a gas jar that had carbon dioxide gas, and we had put, this is my burning magnesium ribbon. Okay, now we expect carbon particles to fall off, so we observe them as black particles of carbon on the sides of the gas jar. This is the gas jar. Next, this oxygen, we know oxygen supports burning. So this oxygen enables magnesium ribbon to continue burning for some time. Then it produces a bright white flame. So it continues burning for some time. Then we form magnesium oxide. Magnesium oxide is observed as a white solid. So we say a white solid is formed. Meaning that magnesium oxide is observed as a white solid. Then carbon particles are observed as black solid particles. So observations that we can conclude or that we can pick from here: magnesium continues burning for some time, then it continues burning with a bright white flame to form a white solid, which is magnesium oxide, and carbon, which is observed as black particles. Overall equation. I need to use another understanding for us to get the equation very well. We can also say that since magnesium is higher than carbon in the reactivity series, magnesium displaces carbon from carbon dioxide gas to form magnesium oxide, and carbon remains alone. 2 oxygen atoms, I'll put a 2 here and a 2 here. So this summarizes the reaction between magnesium and carbon dioxide gas. Briefly, we say that magnesium has been oxidized to magnesium oxide because magnesium has gained oxygen to form magnesium oxide. We also say that carbon dioxide has been reduced to carbon because carbon dioxide has lost an oxygen atom or oxygen atoms to form carbon. So that means that we had reduction, so had oxidation. Okay, reaction number 2. Reaction with calcium hydroxide. We also call it lime water. Okay, calcium hydroxide is an alkali. That's what I need us to remember. Alkalis are under bases. An alkali is a substance which, when dissolved in water, produces hydroxide ions as the only negatively charged ions. Then, carbon dioxide gas being an acidic gas, when we react it with calcium hydroxide, which is an alkali, it is like the reaction that we used to have of an acid plus a base, which always gives us a salt and water. You all remember that alkalis are under bases. So it's the same thing as an acid plus an alkali gives us a salt and water. So when carbon dioxide gas is still in limited supply, this will give us calcium carbonate plus water. Calcium carbonate is an insoluble salt. Where do we pick this from? All carbonates are insoluble in water except sodium carbonate, potassium carbonate, and ammonium carbonate. That's why we observe this as a white precipitate. Now, we expect maybe calcium hydroxide to be in a beaker or in a test tube, assuming that it was in a test tube. This was my lime water. Lime water is the same as calcium hydroxide. Okay, so when air is entering, air contains carbon dioxide. So when carbon dioxide is entering into the solution of lime water, or when it is dissolving in a solution of carbon dioxide gas, you cannot calculate the volume of carbon dioxide gas that has been pumped in it. So after some time, after this reaction, the first step of the reaction, when carbon dioxide is still emitted, in our beaker or in our test tube, in our case we're using a test tube, I have both calcium carbonate and water. So when we continue adding more carbon dioxide gas, we expect that calcium carbonate that had been formed plus water, because for them we have left them in that beaker or test tube plus excess carbon dioxide gas, all of them they give us calcium hydrogen carbonate. Calcium hydrogen carbonate is soluble. It is a soluble salt and it is observed as a colorless solution. This means that when carbon dioxide gas reacts with calcium hydroxide, we form an insoluble salt of calcium carbonate and water. The insoluble salt is observed as a white precipitate. In that case, if we are using lime water, we can say that it turns milky. Milky representing the white precipitate. Okay. Lime water being calcium hydroxide, the milky solution representing the white precipitate. Then lastly, in excess carbon dioxide gas, calcium hydrogen carbonate is formed, which is soluble, and it is observed as a colorless solution. NB. This is taken to be the confirmatory test of carbon dioxide gas. Okay, then the last reaction is still reacting with an alkali, but here it is number 3, reaction with sodium hydroxide. So again, sodium hydroxide is an alkali. Then we know carbon dioxide gas is an acidic gas. So see, we need that image of an acid reacting with an alkali or base to give us a salt and water. Okay, so we have an acid. In our case, the acid is the acidic gas. We are dealing with acidic gas. We have carbon dioxide gas plus sodium hydroxide. This gives us still a salt and water. Sodium carbonate plus water. All carbonates are insoluble in water except sodium carbonate, potassium carbonate, and ammonium carbonate. So this is a soluble. This is a soluble salt. Since it's a soluble salt, then we can always take this to be colorless.